If you look around, you're pretty much surrounded by shapes, polygons, the tiles on your floor, the stop sign down the street, even the screen you're looking at right now. And every single one of them, from a simple triangle to something way more complex, follows this really cool, kind of secret set of rules for its angles. And today, we're going to crack that code.
So here's the game plan. First up, we'll make sure we're all on the same page about what a polygon even is. Then we'll jump into the secret formula for the angles on the inside. From there, we'll see what happens with those perfectly symmetrical shapes, the regular polygons. After that, we're going to uncover an incredibly simple rule about their exterior angles. And finally, we'll tie it all together and see why any of this actually matters in the real world. Okay, so let's start with a little puzzle. Check this shape out. It's a decagon, 10 equal sides. Now, how in the world could you figure out the exact size of one of those angles inside without grabbing a protractor? It seems kind of impossible, right? Well, stick with me, because by the end of this, you'll know exactly how to solve this, no problem at all. Let's dive in. All right, first things first, let's start with the absolute basics and define what we're even talking about. What exactly is a polygon? It's actually pretty simple. A polygon is just any flat, two-dimensional shape that has at least 3 straight sides, and those sides all connect to form a closed figure. So yeah, we're talking triangles, squares, pentagons, hexagons, all those guys. But shapes with curves, like a circle, or any figures that are left open, sorry, they're not in the club. Okay, now for the fun part, the angles inside the shape. There's this really clever trick for figuring them all out, and the secret, believe it or not, comes from the simplest shape of them all, the triangle. So here it is, the big secret. You can take pretty much any polygon, pick one corner, just one, and then draw straight lines from it to all the other corners. When you do that, you slice the shape up into a bunch of triangles. And since we all know that the angles inside a triangle always add up to 180 degrees, well, now we're getting somewhere. And once you start doing this, you see this amazing pattern emerge. A quadrilateral, like a square, has 4 sides, but you can only make 2 triangles inside it. A pentagon has 5 sides, and you get 3 triangles. A hexagon, 6 sides, gives you 4 triangles. You see it, right? The number of triangles is always exactly 2 less than the number of sides. And that little pattern we just found, well, that gives us this incredibly powerful formula. To find the sum of all the angles inside any polygon, you just take the number of sides, we'll call it n, subtract 2, and then multiply that by 180. Boom. That's it. That's the master key. Okay, so that's the total sum of all the angles. But what if you just want to know the size of one single angle? Well, to do that, we need to focus on a special kind of polygon, the regular ones. So what's a regular polygon? Just think of them as the perfect, supersymmetrical versions of shapes. We're talking about an equilateral triangle or a perfect square. In a regular polygon, every single side is the exact same length, and every single angle is the exact same size. And because they're so perfectly symmetrical, figuring out one single angle is, well, it's actually pretty easy. We already know how to find the total sum of the angles, right? So if all the angles are identical, we just take that total sum and divide it by the number of angles, which is, of course, the same as the number of sides, n. All right, let's put this to the test with a regular hexagon. Okay, so it has 6 sides, so our n is 6. First, we find the total sum of its angles. So that's 6 minus 2, which is 4, and 4 times 180 is 720 degrees. Now, to get just one of those angles, we divide that total of 720 by the 6 sides, and we get 120 degrees. Simple as that. Each angle in that perfect hexagon is 120 degrees. All right, so we've got the inside angles locked down, but what about the angles on the outside? Well, this is where things get even simpler, and honestly, a little bit weird. There's this one magic number that always works. First off, what even is an exterior angle? Well, imagine you extend one of the polygon sides, just drawing a straight line out from it. The angle that forms between that extended line and the next side of the shape, that's your exterior angle. And the cool part is, the interior angle and the exterior angle at any corner always form a perfect straight line, so they always add up to 180 degrees. So this leads to a really interesting question. What happens if we add up all of the exterior angles of a polygon? Are we going to need another complicated formula that changes depending on how many sides there are? Nope. The answer, and get this, is always the same. 360 degrees. It's that simple. It doesn't matter if you have a triangle or some crazy 100-sided shape. The sum of the exterior angles is always 360. It's just one of those fundamental rules of geometry. So cool. But why? How is that even possible? Well, think about it like this. Imagine you're walking along the edge of any polygon. Every time you get to a corner, you have to turn to stay on the path. And the angle of that turn you make? That is the exterior angle. So by the time you've walked all the way around the shape and you're back where you started, you've made one full rotation, a complete 360-degree turn. Okay, this is all really neat math, but you might be thinking, so what? Why does this actually matter? Well, it turns out these rules are absolutely everywhere, from the patterns we see in nature to how we design buildings and even video games. Tiling a floor is a perfect example of this. You ever wonder why honeycombs are made of hexagons? It's pure math. As we calculated, a regular hexagon's interior angles are 120 degrees. So if you fit 3 corners together, you get 120 times 3, which is 360 degrees. They meet perfectly with no gaps. But now try that with regular pentagons, with their 108-degree angles. You just can't make them add up to 360. You're always left with these weird, awkward gaps. The geometry just won't allow it. And this quote really just nails the whole point. It's not about memorizing formulas for a test. It's about recognizing the hidden logic in the world all around us, a logic that lets us build, design, and just understand our universe a whole lot better. So let's do a super quick recap. Here's your brand new Polygon Angle Toolkit. To find the sum of all the angles on the inside, it's the number of sides minus 2 times 180. To find just one angle in a regular polygon, you just divide that sum by the number of sides. And the sum of all the exterior angles, that's the magic number, always 360 degrees. So it turns out the world of shapes isn't so chaotic after all. It's all built on a few simple, really elegant rules. Oh, and remember that 10-sided decagon from the very beginning? Well, using our new formula, we know each of its interior angles is exactly 144 degrees. And now you know exactly how we figure that out. So the only question left is, what other patterns out there in the world can you now decode?